very good evening and a warm welcome to each one of you from Knowledgehut. And thank you for joining us for today's session. We are glad to have you with us today. I would like to introduce our speaker for today, who is Mr. Priyal Karekar. So, without any delay, I would like to hand over the session to Mr. Priyal.
Okay, thank you, Soumya. A very warm welcome to all of you guys, and good evening, everyone, for the people who are joining in from India, and good morning for people in the other country. So my name is Priyal. I have experience of about 23 years in the IT services and product industry. I am a SAFe program consultant and agile coach. I have trained about certified and trained about more than 1,000 certified professionals in SAFe and Kanban. So today this is a series of 3 webinars. So today is the part 2 of the series, and today is the part 2 of the series. And in this particular series of the webinar, we will be uh, talking about 3 principles. Okay, and in the previous part 1 we covered 3 principles. Okay, so these are the continuation principles from the part 1 to the part 2. Part 1 recording is already available on YouTube, so if you guys have missed the part 1 recording, you can go ahead and look into the part 1 recording and then come to the part 2 of this. But having said that, the principles are independent, and you should be able to understand this with little knowledge of lean and agile. So without any further ado, let us go ahead with the rest of the principles. Okay, next 3 principles of SAFe Lean-Agile. So we are talking about in today's agenda the SAFe principles part 2, which is nothing but the next 3 principles: build incrementally with fast integrated learning cycles. Then the next principle is base milestones on objective evaluation of working systems, visualize work, limit work in progress, reduce batch sizes, and manage queue lengths. That is our 3 principles. So that is the agenda for today. And how can we apply this in our organization context? And what do these principles mean? So talking about build incrementally fast with integrated learning cycles, that's the first principle. So in the first principle, we will take an example of, in the waterfall approach, what happens is when we are developing the software using waterfall approach, the cost begins immediately and it gets accumulated fully till the product is delivered at the end, right? So in the waterfall, the product gets or the project gets completed only at the end. Okay, and it is a longer time box, right? Not even a time box. We have a longer duration of the project, and eventually there are certain problems like the projects run out of money, and with only few features delivered, there is lack of feedback and customer engagement. So during the development of waterfall, there is lack of feedback, there is no customer engagement, there is no feedback. So there is a lot of risk until the program is completed or the project is completed. And eventually what happens, there is loss of trust with the customer. So in lean agile development, this problem is approached a little differently, right? So what we do is we do plan, do, check and adjust, or PDCA cycles. So that is what is the picture which is given here. So we have PDCA cycles here: plan, do, check and adjust. And in these plan, do, check and adjust, we do a small experiment. Okay, we quickly we execute that experiment, we inspect and adapt and quickly adjust and collaborate with the customer and to check whether the things are working with us or not. Okay, so we build incrementally and we apply fast learning cycles, which will help us to learn better in terms of whether whatever experiment we have done, does it even work for us or not. So how do we do this? Plan, do, check and adjust by using iterative learning cycles. Okay, our learning cycles are shorter cycles which will help us to give faster feedback, right? And these cycles will reduce the risk of failures. And we have seen this incremental approach in the lean and agile development. Now what if we are doing large scale product development? with multiple teams, how does that work, right? So now, how do we do this integration points, or how do we build incrementally with fast integrated learning cycles? Now here I'm putting a question. Assume that we have to build a prototype of a vehicle which contains multiple parts. So here you can see a car which contains multiple parts, and assume that every part is built by each of the team. Now if we have to build this part, if we have to build this car, how do we demonstrate that our prototype is working? We can demonstrate that the prototype is working only when all the parts are integrated, right? Even if one part is not available, this car will not we will not be able to demonstrate the car. And the prototype is not complete until the all the parts are available. And even, for example, a small nut or bolt is missing, okay, we will not be able to integrate and show the overall car as a solution. So what we learn from the PDCA cycle is nothing but it accelerates learning. But when there are multiple teams which are working together, how do we accelerate that learning? Okay, that's the question. So every team does the PDCA cycle at a team level. So where there are, uh, all the individuals at a team level come to do plan, do check and adjust, and they integrate at a team level. So there is a team level PDCA, and we take a team level feedback. And once, when the team of teams multiple parts are developed, they can do the integration points at the end of the PDCA cycle, and that is nothing but team of team integration, which is nothing but agile release train PDCA cycle. Now, if there are multiple agile release trains, art of arts, at a solution train level, you can again do multiple, again one another level of integration. So the integration points brings all the teams working together to accomplish the value together. Okay. Now the question is, how often do your teams integrate? For example, now when we talk about this particular car itself, right? So if all the teams here, which is nothing but control unit team, air conditioning team, auxiliaries, cooling system, powertrain, power electronics, all of these teams are evolving or developing smaller increments every iteration and integrating together, then you are continuously integrating, like how the dots have been showed here. So you are continuously integrating. Okay. However, sometimes what happens is, let us say the cooling system does not deliver uh, does not integrate as frequently as rest of the parts. So in that, what happens is nothing but you are carrying a risk of not integrating the cooling system for about one iteration or two iteration or three iterations or four iterations, and your system will evolve as slow as your slowest integration point. So you need to integrate as frequently as possible, and you need to synchronize all these integration points. When I say synchronize all these integration points, synchronizing integration point along with your development will help to create a pull event with all the teams and all the stakeholders coming together and integrating their work, right? So when you are working on large scale products where there are multiple teams, you need to pull, you need to synchronize all the teams work, okay, together at the end of every, small short iteration, so that you can achieve the synchronization integration points quickly. And integration points are critical events which will bring all the teams uh, working together to accomplish the value which is delivered. Now that was nothing but building incrementally fast with integrated learning cycles. Now the next principle is about base milestones on objective evaluation of working systems. Now, base milestones on objective evaluation of working systems, what happens here is we are aware about, the phase gate milestones. Now, in phase gate milestones, what happens is, so in waterfall development, we have phase gates. The requirements complete phase gate, then the design complete, then the code complete, then the test complete, then the deployment complete, and so on. And that is what is your first picture, which is showing here, right? So the first picture talks about the phase gates, but eventually what happens is the solution may not work because we are doing our design decisions too early. So if you look at the second picture here, what it shows is, if you take waterfall forces here to take a point blank solution. So phase gate forces us to lock the uh, design decisions too early, okay, and one single point solution, and we think that the solution is in this line and we try to achieve that. But however, over a period of time, and this is the cone of uncertainty, over a period of time what happens is there is no enough time to adjust in terms of in terms of based on the feedback, okay, and the actual solution possibly could be here. So eventually it is difficult to adjust, and we may build upon the wrong design also, and there is a huge cost which will be incurred. So phase gates create huge cost because there are longer queues, because you are talking about a bunch of requirements, so bunch of design and bunch of long queues, and lot of work is in progress, and it is very difficult to adjust the solution at the end. Now, what is the recommended approach for us? And there is a sentiment here from Danter Oosterwal from the Lean Machine. There is no correlation between the exiting the phase gates on time and the project success. So even if you have completed the phase gates in time, there is no correlation between exiting phase gates on time and the project success. However, data suggested that the inverse might be true, right? Now, what is the recommended approach? So assume that you want to build, a next gen product, right? And you're the product management of a startup. And how would you basically evaluate your working system? Now, SAFe helps us to do this by demonstrating, okay, with a system demo. So there are at the every whenever the feature is completed, at the end of every iteration, you can do a system demo for whatever features are completed, and you can show the system demo. So the system demo is nothing but the integrated demo of team of teams. And in the next picture, what we can see is, based on the system demo which we have shown, okay, we can measure the progress objectives, we can measure the product objectives, and we can look at the product metrics, and we can look at the process metrics. So when we talk about progress objectives, whether the business objectives are achieved, whether the features required by the business are delivered, okay, what is the current release status or the implementations, how many features have been delivered. So we have to measure in terms of how are we progressing in terms of our objectives. The next one is about product metrics. So whatever system demo we give, for the features which are demoed, we can look at the solution or the product performance metrics. How is our solution performing? How is our product performing in terms of operational capabilities, whether it is giving us the desired outcome in terms of the functional requirements or the non-functional requirements. uh, then also the next one is feedback from the market or the customer also, which will help us to evolve the product. So we can gather the feedback from the market or the customer. That is another thing. So in terms of the process metrics, we can look at the team velocity, program predictability measures, team self-assessment, lead time. How are we doing in terms of the overall process, right? So when you talk about base milestones on objective evaluation of working systems, we take a bunch of design options and requirement options, okay, and we continuously iterate and adjust and iterate to a optimum solution. So objective milestones help us in learning, okay, and allow for continuous cost effective adjustments towards the optimum solution. So they continuously iterate to the right solution. They incrementally build the solution and adjust to the solution by taking the feedback. And finally, they arrive at the optimum solution. Then the next principle here, which we have, is visualize work, limit work in progress, reduce batch sizes, and manage queue lengths. So here, this is a little heavily loaded principle with a lot of items in it. Okay. So we will talk about visualization of work. So in terms of visualization of work, the team can use visualization boards like Kanban boards to visualize the work. When we talk about Kanban, Kanban is a Japanese word which is having two meanings. One of the meaning of the Kanban is nothing but visual board. Second meaning of Kanban is nothing but a signal or a pull signal. For the first meaning is nothing but visual board or a Kanban board or looking at a billboard, which will again give a signal to you, right? In terms of where we are in terms of our status, and looking at the board, we can know what are the work items which we are actually doing, and it will make our all the work which is visible. The second meaning of Kanban is nothing but about the pull signal. That pull is nothing but I have capacity that I can pull more work, right? Now, Kanban board has couple of key elements which are listed on the slide here. One is the board itself, the work items on the board. The work items on the board are nothing but, here in this case, I'm talking about the team level board. The team level board contains user stories, or the team level board may contains uh, defects or technical debts. So these green colored items could be the work items at a team level. So then you may have workflow stages, which is the team backlog. Then the team backlog can go to the next workflow stage, which is analysis in progress. And these are the items which are ready in analysis. Then maybe it will go to review, and maybe it will go to build in progress, build done, then integrate and test, and then accepted. Now the workflow stages for every team may be different, and you cannot copy a Kanban board from one team to another team. You need to define your own workflow stages. So whatever workflow stages you may have, you can add them here. Then the next element of the Kanban is all about visualizing work is nothing but limiting your work in progress limits. It is nothing but number of items which you can have in progress. Now, why we have to limit the work in progress? If we limit the work in progress, we can work on shorter queues or smaller queues. We need not start all the work in progress, all the items in progress, because one by one. So you are focused on a particular item, and you can close the item faster, and you can release the item faster to the customer. So you can reduce or minimize your lead times for each and every item. So that is the reason you can minimize your WIP limit. Okay. So sorry, you can add your WIP limit so that you can minimize your lead time. Then you can have commitment points. The point here is nothing but from the team backlog to analysis, how many number of items which you are taking. This could be one of your commitment point, and this could be your delivery point here. And the time taken from the commitment point here till here is nothing but your lead time. So the time is nothing but, if the customer is asking when will I receive the item, it is nothing but the time from where you have committed till your delivery point. So you can visualize all of this work using Kanban board. Now, the next item which we need to talk here is nothing but, so we talked here about visualizing work, limiting WIP. Now we will talk about transaction cost and holding cost. Now, before we get into transaction cost and holding cost, let me give you an analogy of what is the transaction cost and holding cost. Let us think that at home I eat an egg, and when I eat an egg, right, I need to buy an egg, right? So my can I stock how many eggs I can stock at home? So if I'm eating an egg every day, can I buy 365 eggs and keep it in my house? Okay. So when I buy 365 eggs and keep it in my house, it means I need to buy that many refrigerators to stock my eggs. So that is nothing but the holding cost. My holding cost becomes high when I go and stock so many eggs at a given point in time. So now, because to reduce the holding cost, because I cannot afford to buy so many refrigerators to stock the eggs, okay, I will buy an egg whenever I eat an egg. So today I want to eat an egg, I will go to the shop and buy an egg. I'll buy only one egg. Then tomorrow I want to eat an egg, I will go to the shop tomorrow and buy another egg. So eat a egg, buy a egg strategy is nothing but which will increase my transaction cost, because I need to spend time to go to the shop and buy the egg and come back, right? So there is a transaction cost involved in that. So transaction cost is nothing but my fuel cost and the time taken, to go and bring and buy that egg. But I'm reducing my holding cost. Now, so that is nothing but the transaction cost and the holding cost. Now the question is, how many eggs I need to buy? How many eggs I need to buy? So if my batch size of the egg is small, okay, if my batch size, if the number of eggs which I buy is small, is nothing but, I'm just drawing a line here, okay, and this red line is nothing but, let us say I purchased about few eggs here, then the holding cost is less, because I need to stock about one egg, two eggs, or five eggs, right? Okay, if I bought many eggs, my holding cost goes up. So as the batch size goes high, the holding cost also goes up. Now the second point here which I want to do here is nothing but the transaction cost. Now if I keep on buying 365x for the entire year, right? So it means if my batch size is high, my I'm going to go one time to the shop and buy all the eggs. So my transaction cost is represented in the green line here now. So the transaction cost is represented in the green line. Okay, so if I purchase higher batch, then my costs are lower, because I go only one time and buy all the eggs and come. But if I eat an egg and buy an egg, my transaction costs are high, right? So now what is my total cost? My total cost is nothing but the green line plus the red line, and that is nothing but what should be my optimum batch size, how many eggs I need to buy. So the optimum batch size is nothing but where these 2 points meet, is nothing but this is my optimum batch size of the eggs which I need to buy, right? Now how do I compare this in our IT industry, right? So when we talk about in the IT industry, now, when we talk about these eggs are nothing but the user stories or the work items which we are building, right? So if you have developed so many user stories and the work items, okay. So if you have developed the holding cost, so the number of user stories which you have parked in the inventory and not released or not taken the feedback, or the delayed feedback, is nothing but the holding cost. The value of the feature diminishes over a period of time. So you have developed some features but you have not demonstrated that to the customer, is nothing but the holding cost. Cost of value delivery, delaying a release to the customer, is nothing but the holding cost. So that is the holding cost. Now what is the transaction cost in software development? Transaction cost is nothing but the cost of preparing and implementing the batch, like testing, deploying, releasing, user training, and etc. So if you are developing user story by user story, the question here is, can you release every user story as and how it is developed? Then the transaction cost will increase. But can you release about 10 user stories? Maybe the transaction cost is optimum. So what is your optimum batch size is the question which we are asking, and that is nothing but this is the sweet spot which we are trying to say. And the blue color line indicates this is your optimum batch size, right? Right. So now let us see this green line, right? So the green line is nothing but your transaction cost. So when we talk about the transaction cost of the green line, okay, let us move this green line up a little bit. Okay. So when I move this green line up, so I'm just going to play this once again. So can you see this green line moving up? Okay. So assume when the green line moves up, the optimum batch size also goes up. So earlier the optimum batch size was here, but now the optimum batch size is here. Okay. So as the transaction cost goes up, the batch size also goes up. It means you need to release, in a bigger batches, right? So if the transaction costs are high, then your optimum batch size also goes up. Now, what happens when the holding cost goes up? So this is another line which I'm talking about. So if the holding cost goes up, what happens? Your optimum batch size reduces actually. So what I'm trying to say is, if the cost of my refrigerator reduces and refrigerators are available for cheap, possibly I will go and buy 365 eggs and put it onto this one, right? So it means if the holding cost goes high, the optimum batch size reduces. Okay. So if the holding cost goes high, the optimum batch size reduces. Now, based on this, what would you do? So you want to bring down your transaction cost. Now, to bring down your transaction cost, what you can do? You can automate things. So reducing transaction cost will reduce your total cost and lower your optimum batch size. And that will increase your predictability and accelerate feedback and reduce your rework also, right? Now, the last part of this principle is nothing but managing queue lengths to managing queue lengths. Now, we have seen this particular picture, we have been in this particular thing, right? So maybe we are in a coffee shop or we are in a burger shop to buy something, right? So when we are in a coffee shop or a burger shop to buy something, okay, uh, we are waiting in the queue here. So we are in the queue. Now the question is, when will my turn come? So we are always thinking, when will my turn come? And it depends on the number of people in the queue. Okay. And it also depends on the rate at which he is processing, the person at the counter is processing the number of items. So if there are about 10 people, so if there are about 10 people in the queue, and if this guy is processing about, 2 people per minute, so the wait time is about, you know, 10 people divided by 2, which is nothing but 5 minutes. Okay. So which is nothing but the 5 minutes. So basically that wait time is nothing but our lead time. Lead time is nothing but work in progress item, and the throughput. Throughput is nothing but 2 per minute, and work in progress is nothing but the number of people, which is 10. So when we talk about work in progress limit, which is nothing but 10, and throughput is nothing but 2, your lead time is nothing but about 5 minutes is your lead time or your wait time. Now, if you have to reduce your wait time, what you need to do? You have to increase your, there are two things. You have to increase your throughput. Okay, that is one way, or reduce your WIP. Now, to increase your throughput, what you need to do? You need to add another person at the counter. Okay, you need to add another person at the counter to increase your throughput. The moment you add another person to the counter to increase your throughput, okay, there is a increase in the cost, and to add a headcount, you need a budget. Now, and in an organization, we are always short of budget, and you cannot get an additional headcount to put it at the counter to increase the throughput. So the best viable or feasible option is nothing but reducing the WIP. Okay. So if we reduce the work in progress is nothing but reducing the queue length, our lead times will reduce. So here the lead times, what we are trying to say is, in traditional development, okay, the list of requirements that which are planned upfront is nothing but a queue. And the problem with waterfall is we define work up to the last date. It means that we are taking all the requirements, we are planning who does what up to the last date, and waterfall creates a long wait time for the new features. But uh, in lean and agile development, what we are doing is we are working on shorter iterations and shorter queue lengths. Okay, we are taking a small chunk of requirements, we are planning in small increments, and we are continuously evolving the increments, uh, continuously evolving the, the solution by working on shorter queue lengths, or short set of commitments. So we are committing per iteration or per program increment. Okay. And when you're working with, when you're managing this queue lengths, it becomes easy for the customer also to add new, uh, new work items. For example, when we talk about, it becomes easy for the customer to add new work items. In waterfall, what happens is he has to add the work items only at the end. But whereas in lean and agile, at the end of every iteration, that is nothing but your queue length, you again do a prioritization or reprioritization. You can add in some item, remove some item, and that is how you can manage your queue length. So these were a couple of principles from these were a couple of principles from today's session, and this ends the three principles. So if there is any question from your side, please put it in the chat, and I'll be happy to take them.
So, and
Okay, sure.
Priyal, yeah, Marika has a question. It is, I work with a lot of solution architects and they have an issue creating tickets in Jira that will spans across multiple sprints. How can I limit that or encourage them to create shorter tickets?
So, Malika, maybe when you talk about tickets which are spanning multiple sprints, right? In SAFe, we talk about requirement hierarchy, which is nothing but epic, feature, and user stories. So when we talk about epic, feature, and user stories are the requirements which should get completed within a iteration. Okay, they are worked by one single team. Features are the requirements which are worked by multiple teams, okay, or one or more teams, which contains bunch of user stories together, which may span multiple iterations. So what your solution architects are actually creating are features and not user stories. And we are using the jargon or terminology of Jira rather than following agile terminologies like features or user stories. So yeah, what possibly I'm just guessing that you guys are doing is you are calling everything as a ticket. So the ticket can be large or small, but you need to classify the ticket whether it is a feature, okay, end user deliverable delivered feature. Then you want to break that feature into smaller user stories, which can be delivered by the teams within a iteration, and then only you will be able to get fast feedback, and then you will be able to integrate those user stories with the other teams user stories and then build the features. That was our first principle. And build incrementally fast with integrated learning cycles and synchronize your learning cycles with your integration points. Then our second one was demonstrating the system demos. Whenever a feature is completed, it means all the user stories are completed. What you are going to do is you are going to do a system demo and see uh, whether you have met the PI objective or the business objective or product metrics or process metrics, how you are evaluating your working systems, right? I hope that helps to clarify up to certain extent, but if you have more follow-up question, I'm happy to take them.
Thank you, everyone.